Hey guys, today we'll be talking about programming and we'll be using C#. So programming in Unity using C#. We'll be talking about how to add force to an object and how to change properties in Unity with your C# script. So open Unity and we are right where we stopped in the last project. And I'm sure you guys watched my last video, basics in the game, how to make a game in Unity. So we're going to go to our player, and the same way we add components to our player in the inspector is the same way we're going to create C# scripts. So we're going to just click add component, and then you see new script. Click new script. We're going to name the script player movement, shall we? So player movement. Player movement. Create. And then you create the script. And it's in C#. So this is how it looks like. Let's zoom in. Yes, so this is how it looks like. This is how your script is. So you're going to go back to your player. And you see that we can also drag. Unity also has this drag and drop mechanism, because we can drag anything from here, the assets, and drop it on any object in the hierarchy. Let's say we coded that in our script we should add force, meaning we should make an object move. Then we can add this script to the player. We can drag and drop it in the player, and it's added twice, but it's already here. So let's say if we want to make the ground move, and then we'll make the code inside the player movement, we can just drag the player movement into the ground. When we click play, the ground is going to move. But that's how the scripts work. That's how they add actions to objects in the game scene. So I think we're removing it from there. We're only leaving it in our player. So now we're going to double tap player movement to open the script so we can start coding. So double tap, and whatever text editor you have will open up the script. I'm using Visual Studio. The link to download Visual Studio will be in the description below. It's taking time to open. Wow. Okay, when it's done loading, it's going to open up this screen. It's going to open up this window. Whichever text editor you're using will open up the script. And in our player movement script, as you can see, we have two methods. That's the start. The thing is, when you're starting programming, everything will look huge and everything will be looking confusing. So since we are just beginners, let's remove the unnecessary things, the things that will not concern us as we are starting this video. So as you can see, Unity has already made some comments for us. Unity has already given us some directions where we're making any script. Now let's take it easy. It's going to be easy. Don't say it hard. It's going to be easy. Trust you. So start is called before the first frame update. This is too much English. Start is called at the beginning of the game. Yes, called once. So void starts, double brackets, then double curly bracket. This is a method. Is a method. Starts is a method. Update is a method. They both carry out functions. They are functions. Functions are methods here. They carry out whatever you put here, maybe the variables and the actions that you want to carry out. So methods. This is a method. This is a method. A start method in Unity. Anything that you write under here, meaning this method runs and is only called once at the beginning of the game. Like once the game starts, this method is the first thing that runs at the beginning. And after it runs at that beginning where the game starts, it never runs again in the game unless it is called later. So we're not going deep inside of it. I'm just explaining what start is. Start is, it calls this function, it calls any code that's written in between these curly brackets at the beginning of the game. Once the game starts, it calls them. Then updates is called once per frame. Okay, this is understandable. Let me add updates is called every frame. Yes, that's what. Let me also add that, because every frame, like every second the game is running, this particular code is called, like, it's running every second. So if we're saying display hello world, we put hello world there to display hello world, it will keep on displaying hello world like forever, every second, as long as that system is still on, as long as that game is still open in someone's phone, to keep on displaying hello world. So let's check out the start and then we'll check out the method. So let's say we want to display, because hello world, if programmers already here, if there are some guys that have already started programming in every programming language, the first thing you start is hello world. So let's show hello world on our console in Unity. So how we display, we can use print, but since we're beginning, let's use debug.log. So debug.log brackets, double quotation, hello world, exclamation mark, then semicolon, because on C#. So once we go to Unity and we play the game, this is the first thing to display. So let's go to Unity. It's compiling the scripts. Okay, our player movement is on our player. That's great, and our player is in the scene. So press play. Now if we go on our console, we're going to see hello world. So yay, we just made our first code. Congratulations. So hello world is showing, meaning it only ran once. As you can see, it ran once at the start of the game. But what will happen if we put hello world in update? And remember, I told you to run every second as long as the game is running. So let's try that. I hope it doesn't crash my system. Okay, so let's press play. Hello world 2831 to 832 to 833. As you can see, the game is running. Let's stop before some smoke comes out. So that's and we're going to be using all of these. Let's try adding force to our player, but we cannot add force yet because we have not. Let's go back to Unity. Remember, I told you that physics can also be coded with the script. We can also add physics. We can also use our code to control the physics. So remember, we already added physics to our player, which was the rigid body. So this is the rigid body. That's the mass property, drag property, angular drag. Let's not go deep into all of this. I just want to use two for now. I'm going to use the force and the gravity. So as you can see, this is the rigid body. And how do we reference this rigid body in our script? Like, reference is too much. How do we recognize rigid body in our script? How do we control the rigid body of the player? How do we control the physics of the player from our code? So we go to our code and then we declare a variable public, because we're calling it public because we want to be able to see it in Unity. If we don't want to see it in Unity, then we can call it private, but we want to see it in Unity. You understand once we go back. So public, what's the name of the component we want to recognize in the code? Rigid body. Yes, so rigid body. You understand? So public, so that to show in Unity, then rigid body, which is the name of the component. So, and after a variable, after defining its publicity and the components, next is the name, your own personal name. So I can name this Pezi. Okay, let's say Pezi Physics. Yes, Pezi Physics. Then semicolon. So this is the name I'll use to call the rigid body of the player every single time. So let's comment this so that we're able to get ourselves. So /to comment. Comment does not affect the code. Everything that is green with / is called a comment in C#. So it won't affect your code. So let's say rigid body of the player. Yes, so Pezi. Okay, let's reduce this. This is too much. Let's see RB. Yeah, RB means rigid body. We understand that. So now that we can reference this, we're going back to Unity to understand what we just did. So it's going to compile the script. Then when we go back to player, player that owns the script, player contains the script. We'll see that on our script we have a space for rigid body, and if we did not make this public, we won't be able to see it here. And Unity is very, very restrictive because we said public rigid body RB. So RB was the name we gave it, and now it won't accept anything there's no rigid body in here. Because if I drag collider, it won't accept collider. It only accepts a rigid body. So the rigid body of the player that contains the script. So rigid body, if I drag rigid body, it accepts it. So that means our script is now connected to the rigid body of the player. Yeah, so now we can edit the properties of the components of the player from the script. So if we go to the script, okay, let's say we want to edit use gravity. And if you see checkboxes anywhere in Unity, when it's ticked, it means it's true. When it's not, it means it's false. So if we are going to edit use gravity, we can say false, true, false, true. So now that it is true, we're going to use the script to make it false. Let's do that. So where should we do it? On the start or on the update? Let's do it in the start because it's just one action. We don't need to do it all the time. Just one. Let's say at the start of the game. Once we play the game, we should make gravity false. Okay, right now gravity is true, so we can say RB, which is the rigid body that we already defined of the player. So we say RB dot use gravity, that which was the name of the property. We can say equals to false. That means when we start our game, rigid body gravity in the player will be false. So just compiling the script, and we're done compiling. Remember to save. Never forget to save. So now that we're here, we can see it's true. When we play a game, it's gonna be false. Watch. Yo, our code is working. We are programmers, yo. So let's do something else that is interesting. You can say RB dot add force. We're going to add a force to the player. That means when the game starts, it's going to add a force that will move the player. So this is showing an error. It's showing an error because add force needs an argument. Add force is a function, and a function always needs an argument. So most functions need arguments. Yeah, like the start function doesn't need any argument. It's empty, as you can see. But add force needs an argument. And what's this argument? The argument is what amount of force do you want to add? Say 100, say 200, say 2000, say 20,000. So yeah, it needs an argument, and the argument must be an int because we're dealing with physics, and physics deals with numbers. Yes. So add force. So add force in what direction? That's what it is. Yes. So add force in what direction? We all know the x-y axis and the z axis. So we're going to add force to move forward, and forward in Unity, as we can see, forward in Unity is okay. This is our player. And we can see that if we want to move the player forward, we go to this transform, the transform of the player. We can see that if we increase z, the player will move forward. So we are adding the force in the z so that the player will move forward. Understand? So we go here, then x-axis 0. We're not adding any force in the x-axis. Then y-axis 0 2. We're not adding any force in the y-axis. Then our z-axis we're gonna add 200. So at the start of the game, we need to add 200 newton of force to our player. So let's check if this works. It should work. It should work. It should work. So if I click play, we're going to add 200 force to our player. Did you guys see the force? We added the force and made him move. Let's turn off our bounce so that we can see the force clearly. So we go to sphere collider, which contains the physics material, and none. Yes, so there's no bounce anymore. So we're going to drag this back a little bit. So we'll see when the force acts. So here, did you see the force? Added the force, pushed it forward. Let's also try and use a cube. How do we use a cube? I duplicated the player, so I'll make a copy of it. Then I came to the sphere and changed the sphere to a cube. So that's a cube. So let's see if it adds force. Yeah, it's added the force, as you can see. There is moving. Okay, deleting that, but I'll open it in a second. A sphere, sorry. So next, we're going to delete the whole start method. I want the player to move forward, yeah, for long. So we're going to put on the orbit. Now, do you understand? Because the orbit runs every second, meaning this player is going to move. Is going to add that force 200 every second, meaning to be on a constant speed. Yes, so paste it here, then we go to Unity and play, and let's see if we can follow our player. Yes, 200. Let's see. Keeps on going and shoots away. Like, go here, you can see. It's too fast for me to catch. Look at the values that are running skelter. So that's what happens every second. It keeps on adding 200, and this is because my system is not very good and not very bad. My system is average, so the number of frames per second FPS, I'll put a link to on the description for you to understand what frames per second is. But frames per second, the amount of frames on your screen per second, it depends on your system actually. So if your system is very good, it will run very fast, and that is not good, because what are people that their systems aren't good? What will your game be like on their system? Your game will be running very slow, and that won't be fair to compare scores. So to even out that condition, that lag or something, Unity added a time.delta. That's what it's called, time.delta time. So it is written. You might not understand it for now, but as time goes on, you get to understand what it is. Time.delta time is a simple code. It's a simple function that's added to a vector 3 argument. A vector 3 argument is an argument that is vector 3 argument. That is the x-axis, the y-axis, and the z-axis. That is the vector 3 argument. So time.delta time can be added to this to make this force even on all frame rates, on all frames per second. You understand? Because now, no matter how fast your system is, it's still going to run the same with no matter how slow another person's system is. The frames per second will still be the same, so that it will not differ in different platforms. So yes, we can increase this to 2000, because if it's on 200, with time.delta time, it will be incredibly slow, because time.delta time is a constant that is trying to reduce all the speed and all the force and keep them on a certain level for all the platforms. So I have to increase this. Let's say 1000. Okay, and it should move normal for us to see. So if I click play, yes, it's moving normally now. It not blast out like before, because now the frames are equal. The time is steady. It's not shaking anymore. It's not blasting. It's not using all the power from the system. It's just using a normal one for all the platforms. So that's what we're going to be stopping for today. In our next video, we'll be doing the movement of the player, to move the player left, right, center, up, down, anywhere in the world. So be sure to like and subscribe, and also stay tuned for our next video. We're going to be moving the player, and link in the description for our last video if you missed it. Also another link in the description for the playlist of how to make your video game in Unity. Thank you guys, that's all for programming. If you love C#, comment below, and if you have any questions, don't forget to comment below. Subscribe to my channel, like, join my Discord server, and also support me to post more videos. Thank you guys. Later.